Good evening, everyone. Good evening, guys. I hope all of you are doing well and you have started your preparations for the upcoming exam PGCET that is most probably to be held in the month of June or in July. Yeah. So this is Komal Gyamlani Santani here. I welcome you all on yours only favorite channel, that is Dhruvika Academy, where you are watching an amazing series of previous year questions and similar exam oriented questions. The objective of this series is to make you comfortable with all the exam oriented type questions so that you are able to get an edge over those questions in the examination hall. So guys, as you all know that since two previous sessions we are discussing the questions of permutations and combinations. So I believe that you all have watched those sessions, liked those sessions, and you have practiced those questions as well. So let's begin our today's session where we are going to practice some more good questions of permutations and combinations. But before that, let me just remind you once again that we at Dhruvika Academy have already started with our wonderful batch named SAMRAT PGCET 2024, right? So here what are we doing? We have started a batch where we are providing you live classes where you get a facility of having live interaction with the faculties and clear your doubts then and then. You get recorded classes as well as that you can use in case you miss any class, and along with entire syllabus coverage we are providing you class test, practice test, 50 plus mock test, and most important guys, the classes are after your college timing, so no overlapping of your college classes and classes at Dhruvika Academy. And one more thing guys, if you join with us now, you get an automatic access to all the upcoming batches till exam, and we are assuring you 100% results along with full syllabus coverage. So guys, quickly join us, and the cost of the batch is also very nominal, that is 3,000 for MBA aspirants and that is 3,500 for MCA aspirants. So quickly join us, join our WhatsApp group where you will get all the notifications, updates regarding the exam, and join our Telegram group as well, Telegram channel as well, where you will get the PDFs of the notes of the sessions held on YouTube sessions and many more things. So quickly join with us and start your preparations, right? The agenda is to help you get maximum score and a good college, right? So let's begin our session guys. In the previous session we did some very good questions of permutations and combinations. I was discussing the question where you were required to use the condition where they said that particular vowels or consonants, they can occupy the even places or odd places only, something like that we were doing in the previous session. So continuing with that session, let's discuss some more good questions of permutations and combinations. So first question on your screen guys, so expect your full participation in the live chat and start the questions along with me, okay, so that you get comfortable. Okay, let's start. First question on your screen guys, in how many ways letters of the word drought can be arranged if both vowels may not be separated? They are saying in how many ways letters of the word drought can be arranged, okay, if both vowels may not be separated. So first you need to see how many vowels do we have in the word they are talking about, and basically is there any repetition in the word. This is something that we are very much comfortable with it through the previous sessions, where I have again and again asked you to first check that whether there is any repetition of the letters in the word or not. So I believe if you highlight the word and observe it very carefully, there is as such no repetition at all, right? All the words, all the letters are unique in themselves, right? Now what are they saying? The vowels may not be separated. That means what? They should be together, right? They shouldn't be separated. That means what? They should be together, right? So we have two vowels we have two vowels and they are saying that they should be together, right? Sequence, they haven't said that first A should sit or U should sit. They said just they should be together, they shouldn't be separated. This is the condition they have given you, right? Now let's solve it. There is no repetition in the letters. This was the first step. Second step, how many letters do we have in hand? 1 2 3 4 5 6 7. So we have 7 letters in hand. Now we want A, U to be together. So already discussed that whatever letters you want to be together, we assume it as 1. We assume it as 1. So what we will do, we'll write AU as 1, right? So we had 7 letters. Out of these 2 letters to be together, assumed as 1. Now we are left with 5 more letters, right? 2 3 4 5. Okay, so in reality we had 7 letters, but since AU to be considered as 1, now we are having 6 letters. Now we are having what? 6 letters. So in how many ways 6 unique letters can be arranged? It would be 6 factorial. It would be 6 factorial, guys, right? Now this 6 factorial is something talking about what? The external arrangement. It is talking about what? The external arrangement. Now this 2 letters AU, they will also be arranged internally, because they haven't said that A should come first or U should come first. They said they should be together. That means there will be taking place internal arrangement between A and U. A and U. So in how many ways these 2 letters can be arranged? 2 factorial, right? This we have already discussed, how 2 factorial, 2 places. For the first place I have 2 options, and for the second place I have 1 option. So 2 into 1 is what? 2 factorial. Okay, so this is the final answer, 6 factorial into 2 factorial. Now if you remember the factorials, so what is the value of 6 factorial? It's 720, right? And 2 factorial is 2, so 720 into 2 will give you how much? 1440. That is option A. That is option A. So I believe the question is clear in your mind. Yes, guys, all those who are watching the session in the live chat can comment. Is this question clear to you? Okay, let's proceed to the next question, guys. It says, in how many ways the letters of the word failure be arranged so that consonants may occupy only odd positions? This pattern is very important, so make sure that you are comfortable with this pattern also. What are they saying? In how many ways can the letters of the word failure be arranged? So first, our foremost duty is what? To check, is there any repetition? Is there any repetition? Yes, no repetition. All the letters are unique in itself. How many letters do we have? 1 2 3 4 5 6 7. Okay, we have 7 letters. How many letters do we have? We have 7 letters. Now what are they saying? Condition is what? Consonants may occupy only odd positions. So let's find out how many consonants and how many vowels do we have first. Okay, consonants, vowels. So F is a consonant, A is a vowel, I is a vowel, L is a consonant, U is a vowel, R is a consonant, and E is a vowel. Okay, so we have 3 consonants and 4 vowels. Now they are saying consonants may occupy only odd positions. So let's find out how many odd positions do we have. Let's find out how many odd positions do we have for 3 consonants. See, if we are having 3 positions for 3 consonants, so as such we don't need to show the combination or selection separately. But if we have more positions and less consonants, then the selection will take place before arrangement, or in other words I should say the application of permutation will take place. But I never teach using the formula of permutation. I just focus that first we need to select and then we need to arrange. Okay, so let's do it, guys. Let's quickly do it. let's see how many odd positions do we have. We had 7 letters all in all, so we have 7 positions. 1 2 3 4 5 6 7. So how many odd positions do we have? 1 3 5 and 7. So we have 4 odd positions, and we have 3 consonants. Okay, so any one place would be left for the vowel. This is but obvious. Okay, so any 3 out of 4 places will be used for the consonants. Now before arranging, we'll find out how many ways do we have to select those 3 places, because we have 4 places and any one is going to be vacant, right? We have 4 places and we have 3 consonants, so any one place is definitely going to be vacant, right? So in how many ways can we select the 3 positions? First we will find it out. So that is, we have 4 positions and we have to select 3 positions out of it. So we can select it in 4C3 ways. In 4C3 ways. Okay, now 4C3 ways, selection done. Now further what we will do, we have 3 places with us for 3 consonants. Now these 3 consonants can be arranged among themselves in how many ways? 3 factorial ways, right? So we'll multiply 3 factorial by this. Okay, now talking about the 4 vowels, the 4 places that would be left. See, 3 even places would be left and any one odd place would be left. So all in all we'll have 4 places, and 4 vowels can be arranged on 4 places in how many ways, guys? 4 factorial ways. In how many ways? 4 factorial ways, right? So this way we need to do such type of question when we have more places and less options to fill it. More places and less options to fill it. So first we need to do the selection, and once we have the number of ways of selecting, we'll just arrange them individually. Okay, we can directly write 7 factorial. We can directly write 7 factorial because there is a condition implied here. Okay, so let's solve it. So how much is 4C3? Anyone in the class? How much is 4C3? See, if you know the properties of combination, you will be able to quickly say that 4C3 is equal to 4C1, and one item out of 4 can be selected in 4 ways. And if you don't know the properties, you can just expand it. And you'll see that 4 factorial, what is the formula of combination, guys? Let me just write for you. NCR, the formula is n factorial upon r factorial into n minus r factorial. This is the formula. So when I'll expand this, it will come out to be 4 factorial upon 3 factorial into 4 minus 3, that is 1 factorial. Now 4 factorial I can factorize in this way, or I can expand it in this way. 4 into 3 factorial upon 3 factorial into 1. So this 3 factorial will get cancelled, and ultimately you'll have 4 as the number of ways to select 3 items out of 4. Okay, but if you know the properties, you wouldn't have been required to do this much of stuff. You would have directly written as 4. Okay, so 4C3 is 4, right? And 3 factorial is how much, guys? 6. And 4 factorial is how much, guys? 24. Okay, so it is nothing but 24 into 24. 24 into 24. So what is 24 into 24? If you know the squares, you can quickly give the answer. So that is 576, option A. Okay, so I believe this pattern is pretty clear in your mind. Let's proceed to the next question. The number of different ways the letters of the word detail can be arranged in such a way that vowels can occupy only the odd position. Now here they have specified about vowels and which position? Odd position. So our foremost duty is to see whether there is any repetition in the letters in the word or not, right? So just zoom it and see. Detail, is there any repetition? No. Fair enough. Now let's count the number of letters. That's 1 2 3 4 5 6. Now how many consonants and how many vowels do we have? D is a consonant, E is a vowel, T is a consonant, A is a vowel, I is a vowel, and L is a consonant. So we have 3 consonant and 3 vowels with us. Okay, now they are saying condition. What is the condition? Vowels can occupy only the odd position. So let's find out how many odd positions do we have. 1, 2, 3, 4, 5, 6. So the odd positions are 1, 3, 5. So we have 3 places and we have 3 vowels. So the places and items to be placed on those places are same. So selection is not necessarily needed to be showed, because there is only one way of selecting 3 items from 3. Okay, see, you have 3 chocolates with you and you have to select 3 chocolates from it. So there is only one way. Take all the 3 chocolates. So 3C3, you need not to write it, because 3C3 is nothing but equal to 1. So that's why I'm not writing here 3C3. It's but obvious. But if you feel like, no, we wrote 4C3 there, why aren't we selecting the things here? You can definitely write it for the clarity of the concept, that 3C3 here is equal to 1. That's why I've just ignored it. Okay, that's why I've just ignored it. So 3C3, I'm writing for your clarity, right? 3C3, it's equal to 1. Now 3 vowels can be arranged among themselves in 3 factorial ways, and 3 consonants can be arranged among themselves again in 3 factorial ways. So 3C3 is equal to 1. 3 factorial is 6. 3 factorial is 6. 6 into 6 is 36. That is option B. That is option B. Okay, right? Now next question, guys. The number of ways of arranging 6 boys and 4 girls in a row so that all 4 girls are together. Now what are they saying? They are saying, in how many ways can you arrange 6 boys and 4 girls in a row so that all the 4 girls are together, right? So we have 6 boys and 4 girls. 4 girls to be sat together. So we have already studied this. Whatsoever items, if have to be placed together, we consider it as 1. We consider it as 1, right? So 6 boys, B1, B2, B3, B4, B5, B6, and 4 girls, G1, G2, G3 and G4. These 4 girls will be sitting together. So we'll consider them as one item. We'll consider them as one item, right? So 1, 2, 3, 4, 5, 6, and then 7. Then 7. So first of all, we'll be doing the external arrangement. First of all, what we'll be doing? We'll be doing the external arrangement. Okay. So 7 items can be arranged in how many ways? 7 factorial ways. 7 items can be arranged in how many ways? 7 factorial ways. Now in how many ways these 4 girls can be made sit among themselves? 4 girls can be made sit among themselves in how many ways? 4 factorial ways. How many ways? 4 factorial ways. So this 7 factorial is about external arrangement, and this 4 factorial is about what? Internal arrangement taking place among the girls. Okay, so 7 factorial into 4 factorial, that's option C. So I believe this pattern is pretty clear in your mind. Okay, so let's proceed, guys, to the next question. The number of words that can be formed using the letters of petrol such that the words do not have P in the first position is. Now this is something, a very easy question placed for you, right, where you can score full marks, right? The number of words that can be formed using the letters of petrol such that the words do not have P in the first position. The condition is that you don't want P in the first position. Okay, so what is our foremost duty? We need to see whether there is any repetition in the letters. So observe, guys, is there any repetition in the letters? No, all the letters are unique among themselves. How many letters do we have in our hand? 1, 2, 3, 4, 5 and 6. So we have 6 letters and we need to arrange them. on 6 places. Now what are they saying? P cannot come on the first position. See, if there would have been no condition, we would have simply written like this: 6 into 5 into 4 into 3 into 2 into 1, that is 6 factorial. But they have placed the condition that P cannot sit on the first place. Okay, so how many options do we have for the first place? Out of 6 letters, P cannot sit on the first place, so basically we have 5 options. Basically we have how many options? 5 options. So I'm going to write here as 5. Okay, now out of these 5, anyone is going to sit here. You'll be left with 4 options plus the P, which was not available for the first place but is available for the next places, right? So for the second place, how many options you are left with? You are left with 5 options. You are left with 5 options. Are you getting how you got 5 for the second place? Are you getting how you got 5 for the second place? You had all in all 6 letters in your hand. For the first place, they are saying P is not available, so you wrote 5 options for the first place. Now out of those 5 options, anyone is going to sit here. You'll be left with 4 options plus P, which was not available for the first place but is available for the second place. You can use it for the second place, so we can have 5 options for the second place. Okay, for the second place we have 5 options. Now again, out of this, one will sit here. You will have 4 options for the next place, then you'll have 3 options, then you'll have 2 options, and you'll have 1 options. So if you'll observe, what is this? 5 into 4 into 3 into 2 into 1, it is 5 factorial into 5, right? So how much is 5 factorial, guys? 120 into 5, that is 600. That is 600. Okay, okay, yes. Are you all who are watching the class able to understand? Yes. All right, next question, guys. Find the number of arrangement of 5 things taken out of 12 things in which one particular thing must always be included. Must always be included. Now what are they saying? You need to be very, very clear that you have 12 things with you and you want to have 5 things out of that, and you have to select 5 things out of 12 things, and they are saying that out of those 5 things, there is one particular thing which is for sure there in the selection. That means we actually need not to do the selection of that. It is confirmed that that particular thing is in the group, right? So basically we need to make selections for 4 things, right? I'll repeat once again. What are they saying? You need to find the number of arrangements, okay, of 5 things taken out of 12 things. So first of all, you need to select those 5 things out of 12 things, right? If there would have been no condition, what we'll be doing, we'll be first selecting 5 things out of 12 things. So in how many ways 5 things can be selected from 12 things? I am just explaining you that if there would have been no condition, what we would have done. Understand very carefully what I am saying. If there would have been no condition, what we would have done to arrange this 5 things that we need to select out of 12 things. So first we will select 5 out of 12. So we would have written like this: 12C5. Now you have selected 5 things, and these 5 things can be arranged in how many ways? 5 factorial ways. This could be the way to do if there would have been no condition. But they have given you the condition that out of these 5 things, there is one thing that is for sure there to be selected. So we don't have a choice for it. We are sure that there it is to be included in the selection. Like for example, I say that we are making a cricket team, okay, and Dhoni is there. Dhoni is for sure to be there in the team. So do we have to make selection for Dhoni? No, we know that we have Dhoni in the team. Suppose that we have 15 members and we need to make a cricket team of 11 members, and it is for sure that Dhoni will be there in the team. So basically, how many cricketers do you need to select? You need to select 10 cricketers. Out of how many cricketers? 14 cricketers. obviously Dhoni will get reduced from it. You will have 14 options and you'll have to select 10 options from that. Are you getting it? Are you getting it? I believe the question is clear to you. So basically N and R both will get reduced by 1 when they say that a particular thing must always be included for the selection purpose. Okay, so basically we need to select 4 out of 11. Okay, 1 is for sure there, so no need to do selection of it. So that would be 11C4, 11C4, right? 11C4 we'll be selecting it. Now those 4 items selected and 1 already selected, so 5 items you have. Those 5 items can be arranged in how many ways? 5 factorial ways. So you'll write here 5 factorial ways. Okay, just multiply by 5 factorial. So I believe 11C4 why I have written it is pretty clear. Okay, right, so we'll just solve it. 11C4 can be written as what? 11 factorial upon 4 factorial into 7 factorial. So how I wrote this? I know that NCR is equal to what? N factorial upon R factorial into N minus R factorial. So 11 factorial upon 4 factorial into 7 factorial. So how can I solve it quickly? So the smallest factorial I'll be opening completely, 4 into 3 into 2 into 1, and the biggest factorial I'll be opening till 4 places. It is 11 into 10 into 9 into 8, right? And then we have 5 factorial with us, right? Now 4 2s are 8 and 8 cancelled, 3 1s are 3, that is 3 3s are 9. So we have 330 into 120. So 12 into 33, it's how much? 3 2s are 6, 3 1s are 3. Double 0, that's 39,600. That is 39,600, option C. Okay, so I believe the questions of today's session are pretty clear in your mind. These are very, very important questions, and you will find similar questions in your exam. So let's conclude our today's session. Make sure that you watch the session and solve the questions and get an ace over this question, because you are going to meet this question again in your exam. So in the next session, I'll be bringing some numbers related questions for you so that you get comfortable with those scenarios also. So see you in the next session with further more interesting questions. Till then, take care of yourself. Bye bye. Have a good day. Thank you so much.